Hello guys. Hello Mr. Misra sir. Hello Mr. Bhagwan. Hello Mr. Varun. वेलकम यू ऑल टू एआई की पाठशाला। एआई की पाठशाला आपकी अपनी पाठशाला है और जो भी सेशन मैं यहाँ कंडक्ट करता हूँ इट्स एब्सोल्युटली फ्री एंड आई यूजुअली कंडक्ट लाइव सेशन एट 9:15 AST and anyone of you who wants to join my live session absolutely free of cost, you can go to the description section of the video and join my Telegram group. You can also suggest me which topic you want me to cover in the live session. I will take care of that. One of the student, Mr. Varun Soni, has requested me to cover the NumPy, so I am specially conducting this session of NumPy for him. He's a student of NSUT. So we already have covered 2 sessions in NumPy, and this will be the 3rd session, and it is completely hands-on. So keep coding along with me. So that's all. Let me share you my screen program. What we used to do, it is required to import NumPy in our program. So for importing, we used to type import NumPy as np. Fine. So let's import it. Let's import it. So it is imported. Now, today we are going to learn some basic operations. Some basic operations we are going to study. Some basic operations of array. So let's understand this operation. Let's create one array. A is equal to np. We already know how to create an array. np.array. And those of you who are attending this session for the first time, so you guys need to watch the 2 sessions that I have already conducted before. In that session, I have already covered in very extensively basic things, and very simple things is there. So you will not find any issue in understanding. So let's create an array. So 1, 2, 3, 1, 2, 3, 4. So this is the array I have created, and I want to print this. So let's print this array. So 1, 2, 3, 4. This is the array that has been created. Now I want to perform certain operations on this array. The first operation that I want to perform is the addition operations. So let's see if I will write a plus 1. See, this is my array. This is my array. This is also called vector. And this is my scalar. This is not a vector. This is my scalar. So I want to add, this is called addition of a scalar into a vector. So this is, if this was my array, this is my array, and I want to add 1 inside this array, this is scalar. So how this operation will perform? So this operation get performed like element wise. Let's say this is my array, this is my array, this is my array. This is my array, and let's say 1, 2, 3, 4. So if I add a scalar to this array, what will happen? Element wise operation will get performed. That is, this element, 1 is added to this element, 1 is added to this element, 1 is added to this element, and 1 is added to this element. Each one of the element of this array, in each one of this element of this array, 1 get added. This way, the scalar addition takes place. So let's do it. Let's run this code and see what happens. If I do, can you see? If 1 is added to 1, I am getting 2. 1 is added to 2, I am getting 3. 1 is added to 3, I am getting 4. 1 is added to 4, I am getting 5. So this is how the scalar addition takes place. When we add an array, when we add one scalar into this array, so this is how the scalar addition takes place. So in this way, we are going to see other operations also. So let's see if this is my a, and if I will do this thing, a square, this is my square, a to the power 2. That means if I will square a, what will happen? Each one of the elements of this array a will get squared. 1 will get squared to 1, 2 get squared to 4, 3 get squared to 9, and 4 get squared to 16. So let's do it. Let's run. Can you see? Each one of the element of this array get squared. Now, let me give you one. Let's write another array here, and this array is, let's write it like np.ones. So we already know that what it will create. This will create an array. Let's see what it is going to create. It will create an identity array with 1 in each one of the elements. 4 element is inside this array, and each one of the element is 1. Fine. Now if you will simply add +1 to this, if you simply add b +1, what will happen? B +1. What will happen? Each one of the elements will get changed to 2, because 1 will get added to each one of the elements. Now, let's do one thing. This is my A. This was my A. This thing was my A. What is my A? 1, 2, 3, 4 array 1, 2, 3, 4. And this is my B. 2, 2, 2, 2. Sorry. This is my B. 1, 1, 1, 1, 1. If let's say, let's see what is my A. This is my A. And let's see what is my B. This is my B. So now if I simply do A minus B, so what will happen? Each one of the element will perform its operation. 1 minus 1 will get 0. 2 minus 1 become 1. 3 minus 1 become 2. 4 minus 1 become 3. So this is how the A minus B operation takes place. In the same way, let's see if you will do A multiplication B. So what will happen in this case? Each one of the elements A will get multiplied. A get multiplied to this 1. That means the element of the first element of A will get multiplied to the first element of B, and I am getting 1. First element of A, second element of A, 2 get multiplied to second element of B, I am getting 2. Likewise, the multiplication will take place. That means each one of the 2 elements get multiplied, and finally I am getting this result. This is the result of A multiplication B. Now, if you do multiplication, So this matrix multiplication, we already have, you guys have already studied this matrix multiplication, I suppose in class 12th or class 11th or maybe in class 10th. This matrix multiplication you have. Varun, do you know matrix multiplication? In which class you have studied this matrix multiplication?
In 11th.
In 11th. So you must be knowing about this. So before performing the matrix multiplication, let me first do something. Then, so yesterday we have discussed this concept of creating a diagonal matrix. So let's create a diagonal matrix. What it means? Diagonal matrix. I am just putting the value of the elements that should come at the diagonal position of this matrix. So let's give these four values. So this is the diagonal matrix that I am going to create. Let's create an other elements will be 0. So this is my diagonal matrix. C is my diagonal matrix. 1, 2, 3, 4 comes at the diagonal position and other elements is 0. Now this is one matrix. What I want C multiplication C. If you simply multiply C with C, what it means? It basically means it is simple. It is simply a matrix multiplication. That means this is C, this is C, and you want, and let's say this is also C, same thing. 1, 0, 0, 0, 0, 2, 0, 0, 0, 0, 3, 0, then 0, 0, 0, and 4. This is also C. So you want to multiply this C with this C. So how it get multiplied? Do you remember? First we used to multiply this with this and summing it up. Then we used to multiply this with this row and column. We will take the first row and multiply it with the first column. And we used to sum it all and give the result. Then we used to multiply the second row with the second column. And then we used to multiply the third row with the, is the same way multiplication takes place? Varun, can you please tell me?
Yes, sir.
So this is how the actually the multiplication takes place. And in that case, so here the rows and value of row and column is same. So it won't be any issues, because for multiplication, for multiplying two matrix, there is one condition: the number of rows of first should be equal to the number of column of second. But here the rows, and since both are same, so there is not an issue. Row wise and column wise there won't be any issue. So this is how the matrix multiplication takes place. So if we simply do this, you will get this result. And when you multiply, and finally if you can check it out by manually multiplying it, you will finally get this thing as a output, where the diagonal elements get squared. That means this gets 16, this gets 9, this gets 4, and other elements will remain 0 only. If you multiply this, I suggest you to manually multiply, take one C and manually multiply it and see are you getting the same result or not. Fine. Now let's do one thing. Let's write here. This is one way of matrix multiplication. The second way of matrix multiplication is, if you will write C dot C. This is also called dot product or dot notation. If you will do this thing, this is also a matrix multiplication, but this is called dot multiplication or dot product. You will also get the same result. C dot C. This is also one way of multiplication, and this is also called matrix multiplication. And in both, you will get the same output, same result. Now, after this, there is something called comparisons. So we need to study comparisons. What is this comparisons? Comparisons. So let's understand. Let's take one first. Let's create one array. I'm creating one array, np.array, and inside this array, let's write 1, 2, 3, 4. Fine. Now let's take another. This is my array A. I am creating another. This is my array A, and I am creating another array B. Let's write np.array, and this time let's write here some other values. Let's write 5, let's say 2, let's say 2, let's say 4. So this is my second array. So if I will simply create this array, if you simply run this, my array A and B will get created. If you will see, you can see the element of A and the element inside B is not exactly same. They are different. We have a different element inside the array A, and we have a different element inside array B. Some of the elements are same, like this. 2 here, 2 and 2 is same, and 4 and 4 is same. But these two elements, 1, 5 and 3, 2 is not same. So if I will simply write this comparison, this is a comparison equal to sign. If I will write A is equal to B, that means if I want to check whether these two array are same or not and run this, I will get this thing. Wherever it will compare each one of the elements, it will do the element wise comparison. So it will compare the first element or the element, it will do the index wise comparison. First index of array A will get compared to the first index of array B. Then second, 0th index of array A get first compared to 0th index of array B. Then first, then second, then third. Likewise, it will make a comparison. And wherever, since when it is comparing 1 and 5, since 1 is not equal to 5, so it is giving me false. Here it is comparing 2 and 2, and since it is equal, so it is giving me true. It is returning me true. 3, 2 is not equal, so false. Again, 4 and 4 is equal, so it is. So I am getting true here. So this is how this is how a comparison is made. Now let's say if I will write here, we have created this array already. This array has been key. If I simply write A greater than B, so and run this, again same thing will happen. Likewise, in equal to, this is comparing, it is taking the first value of A, that is 1, and it is comparing it with 5. Is 5 greater than, it is taking 1 and comparing it with 5. Is 1 greater than 5? Tell me, Varun, is 1 greater than 5? False? False. So I am getting false here. Again, it is comparing 2 greater than 2. This is also false.
False.
Again, it is comparing 3 greater than 2. This is true. So I am getting true here. Again, it is comparing 4 greater than 4. This is false. So again, I am getting false here. So it is doing element-wise comparison. So always remember, this is doing element-wise comparison.
Similarly, let me do one thing. Let's here write. I want to this is a element wise comparison. The whole thing here was a element wise comparison. Now I want to make an array wise comparison. I want to compare the whole array, whether this array is equal to that array or not. Because if I will write here like this, a is equal to b or a greater than b or a less than b, it will make an element wise comparison. I want an array wise comparison. So for doing the array wise comparison, let me write here array wise comparisons. Array wise comparisons. So for doing the array wise comparison, first let's create first array np dot array. Let's create np dot array, and let's create this thing 1 2 3 4 1 comma 2 comma 3 comma 4, and thereafter let's create another array b np dot array, and this time I want to write 5 comma 2 comma 2 comma 4. Fine. So this was my second array b. Now let's create one more array here, and I am giving this again. I am giving 1 comma 2 comma 3 comma 4. So these are my three arrays. Let's create the array. If you will see here, you can see my array A and array C both are same, because all the elements inside the array is equal to the elements inside the array C. So both are equal, I know. So if I want to make comparison, so how I can make comparison? Let's compare np dot array and equal this thing equal. If I will select this, and if I want to compare a comma b, so if I will do comparison of a and b, and I know that a is not equal to b, so if I compare, I will get false. But instead of this a comma b comparison, if you will compare a comma c, and I know from my knowledge that c is equal to a, I will get true, because this whole array is equal to this whole array. This is called array wise comparison. If you want to make the comparison between two array, you can make use of this thing. Now next thing comes the logical operations, how the logical operations work in array. So let's do logical operations. Let's understand logical operations. Logical operations. So how these logical operations work? If I write a is equal to, let's create one array, a is equal to np dot array, and inside this array let's write 1 comma 1 comma 0 comma 0, and data type of this is, let's specify Boolean data type. I can also specify the data type. So this was one, and let's create another array, and here I am writing 1 comma 0 comma 1 comma 0. And if you will also, here I am writing the data type of this is also bool, because logical operations will take place only when the values is Boolean value 0 or 1. So that's why I am taking only Boolean values 0, 1, true or false. 0 is called false and 1 is called true. So let's run this. Let's run this. Fine. How the logical operation, how you can perform the logical operation? So you have to write np dot, and if you see log logical or, you can see here there are a lot of logical operations: logical and, logical not, logical or, logical XOR, logical not. These are the logical comparisons. Let's say I want to perform this comparison logical or. So let's select this. And after that, if I will pass these two values a comma b, so it will do the logical comparisons, logical or comparison. Let me clearly make this thing clear to you. So what logical or will do? It will compare the first element of this is 1 and this is 1. 1 means true. 1 means simply true. In Boolean terms, 1 represents our true and 0 represents false. So here 1 means true and here 1 means true. So 1 true true, this is a logical or. So if any one of the two becomes true, it will give me a true value. So true or true will give me true. This is true and this is false, still I am getting true. This is false and this is true. Since it is a logical or, so if any one of the two value will be true, it will return me true. So I am getting true. But here this is false and this is also false. So I am getting false here. This is how logical OR works. And the logical, if I will apply the logical AND, it will work just opposite. For the logical AND to be to get true, both will logical AND will return me true only when both the value will be true. So next thing that I am going to do is I am writing np dot logical AND, and I will write a comma b here. So if I will do this thing, what it is going to return me? It is going to, since 1 and 1, true and true, it is returning me true. 1 0, whether true false, so it will return me false, because it will only return me true when both will be true. So apart from this true, all the three will become false. So this is how the logical operations takes place. Now similarly, this is how the logical operations takes place in case of array. There are certain functions called transcendental functions. I will discuss few of those functions called transcendental, transcendental, TAL. Transcendental functions. It is a tongue twister. Transcendental functions. So let's understand how this. Let's first write one array, np dot array. Let's create one array, np dot. Let's create arrange, and let's give it some value. Let's write 5 here. So if you will create this array A, and if I want to calculate the sign value of this array that I created just now, A. So what I will do, right? I will write np dot sign, and inside this I have to pass this A. It will give you the sign value of this array. If you will simply run, you will get this thing. What it is doing, this sign function is getting applied to each one of the elements of this array. On each one of the elements of this array from 0 to 4, since sign of 0 is 0, so I am getting 0 here. After that, sign of 1, sign of 2, sign of 3, sign of 4. So sign function is applied to each one of the elements of the array, this array, and I am getting this output. In the same way, you can check it for cos, tan, and other trigonometric functions or many other functions. Let me write it right here for, let's take the log function. So what is my A? A is my this thing. If you apply np dot log A, if you pass A, and if you want to perform the log operation on this, so it will let's see what it will return you. It will return you this thing. Since log of 0 is not defined, it is also giving me the runtime warning. Divide by 0 encountered in log, division by 0 encountered in log. So division by 0 is not allowed. Actually, it is an infinity, but still it is giving. If it would have been your normal list or something like that, your normal Python, so it would have given you an error. It would not have like this program would not have run. But this, since this is a NumPy, so we can get the result here. Can you see here? The log 0 is infinity, so you are getting here infinity. After that, it is log 1 is 0, so you are getting 0, and that means the log function is getting applied to each one of the elements present inside this array. In the same way, you can write like this: np dot exponential. If you apply exponential here and run this, you will get this value. That means the exponential function get applied. What is exponential? E raised to the power A. So e raised to the power A or x, the exponential function get applied here, and you will get this result. So what it is evaluating? E raised to the power x. Let me write here. It is evaluates e raised to the power e to the power x. Fine. How to write it? I don't know. Okay, yes. E raised to power x. This is what. So now there is something called shape mismatch. What is this shape mismatch? Thing is, you cannot perform certain operations if the shape of the array is different. One array is having a different shape and the other array is having a different shape. So you cannot able to perform the operations on that. If you will try to perform the operations, you will get an error. This is called shape mismatch error. So let's do this. Let's create first one array, np.arrange, and let's give it this 4. And thereafter, let's create one another array. Let's in this array A that I have created just now, if I want to add another array, np.array, let's say, and inside this array, I am passing this inside in the form of list, I am passing two values, 1, 2. So you know that the shape of this array is this array that I have created just above is having a different shape. This is having a shape of 4, 4, and this is having a shape of 2, 1, 2, simply. So this array will not, the operation will not perform because of the shape mismatch. If I run this, I will get this error. And what is my error? Operands could not be broadcast together with shapes 4, and 2, . This is a one-dimensional array. This is also a one-dimensional array. The shape of this array is 4, . That means this is a one-dimensional array. It is having only 4 rows, and this is having only 2 rows. And this cannot be, the operation cannot be performed because of the shape mismatch. Now, after that, let's see some basic deductions, that is the computing sums and all those things. So let's understand some basic deductions. Inside some basic reductions, first let's understand computing this sum. So let's write one array first. Let's create one array, np.array, and let's create this array 1, 2, 3, 4, 1, 2, 3, 4. So this is my array, and so this is one array I have created, and this array has value 1, 2, 3, 4. If I will do np.sum of x, if I will pass x inside it, so what it will do, it will sum all the elements of this array and give me the output 4, 3, 7, 3, 10. If you will run this, you will get 10. What it is simply doing? This sum operation will sum up all the elements of this array. This is one thing. Now, this second thing is that this is very important, so be careful. Sum by rows and by columns, COLUM, columns. So what this sum by rows and sum by column means? It simply means I want to sum the values. Either I am summing by the rows or I am summing by the columns. That means I will explain you. Just let's first create one array. Let's create one array, and this time I am going to create a two-dimensional array, np.array. For understanding this, let's create two-dimensional array. Let's create 1, 1, and thereafter create here 2, 2. So this, and let's see what this x will return. If I will see, this is my two-dimensional array. So let me explain you this thing first, then we will wait. So this is my two-dimensional array. This is my row 1. This is my row 2. This is my column 1. And this is my column 2. So if if you want to, you can sum this thing. If you want to sum, you can sum this. You have to mention the axis. Axis is equal to 0 means column first, and axis is equal to 1 means row first. So if you want to sum by the axis, see, if you want to sum this, let me clear it out. If you want to sum this by rows, if you want to do a row sum, what it means, this will return you 2, this 1 plus 1 will return you true, and this 2 plus 2 will return you 4. Here I am doing row wise, here I am doing, row wise sum. If you want to do column wise sum, so here 2 plus 3 is 3, 2 plus 1 is 3, and 2 plus 1 is 3. So in both the cases, the output will be different. If you will do a row wise sum, or if you will do a column wise sum. So let's understand this with the help of code. It will, and then we will come again. So for doing a row wise sum, let's do x dot, this is my x dot sum. If I want to sum this, I have to mention the axis. If I mention axis is equal to axis is equal to 0, and then if I will do a sum, let's see what happens. I am getting 3 plus 3. What it means, axis is equal to 0 means it is doing a column wise sum. 2 plus 1, 3, 2 plus 1, 3. So column wise sum is happening here. This is a column. Let me do this again. And if you do x dot sum, and if you mention axis is equal to 1, and if you will run this, you will get another output 2, 4. Here in the first case, when we were giving axis is equal to 0, in that case row wise sum was happening. Each one of the row was getting summed. This 1 plus 2 I am getting 3, and this 1 plus 2 I am getting 3. Here when I have mentioned the axis is equal to 1, column wise sum was happening. How it is happening? This 1 plus 1, 1 plus 1 was getting added, and I was getting this 2, and this 2 and 2 get added, and I am getting 4. So this is the difference between row wise sum and column wise sum, and you have to mention the axis. Either you want to do this sum on axis 0 or on axis 1. So other thing is that let's write another thing. If let's say if there is other deductions, let me here other reductions. If let's say I am creating one array np.array, and I am mentioning this thing 1 to 1 comma 3 comma 2, and sorry. So this is the array. 1, 3, 2 are the elements of this array. If I want to find the minimum, if I will do x dot min, if simply I will do x dot min, it will give me the minimum value that is present inside this array. 1 is present, the minimum value is 1 inside this array, so it is returning 1. If you will do x dot max, so it will return you the maximum value that is present inside this array. So it is returning me 3. 3 is the max value that is present inside this array. So it is returning me 3. Now, one very important thing, one important concept is called argmin. So argmin is something which we will study in very details in optimization. This concept will come in optimization. So I'm not going to discuss the concept right now, but you just need to understand how this function works. If you will write x dot arg min, and what it will return you, let me write it. It will return you the index of minimum elements. Minimum element. What it means? Here, the minimum element is 1. And what is the index value of this one? Can you tell me, Varun? What is the index value of 1?
0.
What?
0.
0. Fine. So if you will do x.argmin, then it should give me 0. Because this argmin is going to give me the index of minimum element. Similarly, if I will do x.argmax, it should give me the index of the maximum element, and index of maximum element is 1. So it should give me 1. Let me write this here. Index of maximum element. Fine. Now, so argmax, argmin, you have understood how this is used. Now let's understand some logical operations. So I will discuss some logical operations. Let me discuss some logical operations here. Fine. Discuss some logical operations. So if I will write, let's write np.all. And inside this, if I will put some Boolean values, let's write true, comma, true, comma, false. It will return me false. Why it is returning me false? np.all, it will check, is all the values true here or not? Since one of the value is false, so it is returning me false. But instead of this thing, np.all, let's see here, if you will put here everything, if you put this thing true, this thing also if you will do true, then it will return you true. That means np.all, it check whether all the values inside it is true or not. If any one of the value will be false, it will return you false. Similarly, now this is one is called np.any. if you will write some, let's say true here, I'm putting this true, then I'm putting these two values as true, false, comma, false. Fine. Now this any will, what we do, if any one of the value inside it will be true, it will return you true. np.any, since one of my value is true, so it is giving me true. So this is the difference between np.all and np.any. Now, if you will do, let's write one thing here. If I will write a is equal to np.zeros, and let's write 50, comma 50, let's say. Right? And after that, if I will write np.any, and then if I will write a is not equal to, let's say 0, what it should give me? Tell me. This is what I am doing. I am doing an array comparison. I have written one array np.zeros. That means all the value inside this this 50, what?
False.
False. Because what I am doing, I am writing these zeros, np.zeros 50, comma 50. What it means? It is creating one array which is having all the values inside this array is 0. And now I am doing this comparison np.any, and what I am writing, a is not equal to 0. Is there any values of a which is not equal to 0? No. That's why I am getting false. Every value is inside this is 0. Similarly, you can write it like this, np.all, and if you will do a equal to a, let's say, what it should give you? It will get you true, because yes, a is equal to a. If you will write, let's write np.all a is equal to 0, what you will get? Let's see. I am getting true, because yes, every value inside it is true. Now let me write some array, and then I will make a logical comparison between these two, those arrays. So I am writing one array, a is equal to np.array, and let's write here 1, comma 2, comma 3, comma 2. Now I am writing another array, and I am writing 2, comma 2, comma 3, comma 2. Fine. I am writing one another array C, and here I am writing 6, comma 4, comma 4, comma 5. Let's see. So this is my array. Fine. Now let's run it. So it get created. Now let's make one logical operation. Let's perform one logical operation here. So I want to write this logic. A less than equal to B, and B less than equal to C. Thereafter, this all. So what will happen? So first thing is that we should understand this. If I will simply run this, I will get something called true, but I am not getting it. Why I am getting this true? So let's understand this first. So how this all logical operation is getting performed. See, first thing that what I am writing, A less than is equal to B. Is A less than equal to B? So what it is doing, this is my A and this is my B. So it is first comparing. So my A is 1, 2, 3, 2, and my B is 2, 2, 3, and 2. See, first it is making a comparison between A less than B. So A is my this and B is my this. So first see, is 1 less than equal to 1, is 1 less than equal to 2? Tell me.
Yes, sir.
What I will get?
True.
True. Then it will make comparison, is 2 less than equal to 2?
True.
True. 3 less than equal to 3?
True.
2 less than equal to true?
True.
So what I am getting? I am getting this true. Everything I am getting this true. Now it is making this comparison between this B and C. B less than C. If I will compare this B 2 less than equal to 6, what I will get? I will get true. 2 less than equal to 4, I will get true. 3 less than equal to 4, I will get true. 2 less than equal to 5, yes, I will get true. After that, what it is doing? AND operation. So I am, by the first comparison, I am getting this thing. By the second comparison, I am getting this thing. And there is a AND operation. This is a AND in between the two. It will also give me what? This AND operation will also give me true, because everything is true. This true and true will give me 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 true. So I am getting this thing. And finally, what I am doing? Dot all. And we know that what this dot all will do. If everything inside will be true, it will return me true. Or if any one of the element inside will be false, it will give me a false. Since each one of the element inside it is true, so it is returning me true. Have you got this point, Varun?
Yes, I understood.
Understood? Any confusion?
No, sir.
Fine. So shall we move ahead? So let me erase this. So this is one good question to understand the logical. Now there is some statistics part is involved. So let me discuss just a little bit of it. These things I will not discuss you the concept wise what is all those things, because those things I will be covering in the statistics part in very details, and in exploratory data analysis I also it will be useful. So there is some, and you must be knowing this statistics. You must be knowing this mean, median, mode, and standard deviation, I suppose. So
Yes, sir.
first, so this is the simple operation. Let's do np.array, and this time let's write this array one. I am writing 1, 2, 3, comma 1. Fine, and let's write one. Sorry. So let's write one another array here, and this time I'm writing a two-dimensional array. So let's write a two-dimensional array 1, 2, 3, 1, comma 2, comma 3. Fine, and this is 5, comma let's say 6, comma 6, comma 1. That's right. So this is my two-dimensional array. So if I want to see, let's run this. If you will do x.mean, that is the average, you will get the mean of the values. That means what is mean? 2 plus 3, 5, plus 2, 7, 7 divided by 4. So you will get 1.75. This is the mean. Median is the middle value. So what is the middle value in these two, in this thing? So if
The
you
two,
will do what?
the 2 and 3.
2 is the middle value 2?
Yes, sir.
Okay, fine. See, let me tell you. See, for calculating the median, what is the, if the value, see here, if you arrange this first to calculate the median, what you used to do first? First, you arrange the value in the increasing order. Fine. So if I will arrange this, I will arrange like this 1, comma 1, comma 2, comma 3. Then you have to see is the, if the number of values, if the total number of values is even or odd. Here the values are even. If the values are odd, then you will get the middle value. But if the if the values are odd, then you will get the middle value. Like let's say I am giving you this thing 2, 3, 5, 7, and 15. So here, what is my middle value? 5 is my middle value. 2 values is here and 2 values here, and 5 is my middle value here. 1, 2, 3, 4, 5. Odd number of elements is there. Odd number. But here in this case, even number of elements is there. So for in the case where the even number of elements is there, you have to take the two values, you have to sum it, and then you have to divide it by 2. So in this case, 1.5 is my median. You got it, Varun?
Yes, sir.
So this was the thing that you must be knowing this. You must have done it before also, I suppose. So for calculating the median, what I do, simply you have to write median, and then you have to write median, and if you will run this, you will get the median. Oh, no. Okay, np.median x. I have not passed x, so let's pass x. So I'm getting 1.5. So this was the thing. But if you want to calculate the, but this was fine. But in case of this two-dimensional array, you have to mention the axis on which you want to calculate the mean or median. So this is my two-dimensional array. So in this case, if I want to calculate the median or mean, what you have to do, you have to write np dot, let's calculate median, and then you have to write, first you have to mention this y, and then you have to mention the axis. Let's write axis as, let's write 1. Let's say 1. 1 means last. So if you will write this, you will get this 2.05. And instead of this, if you will write, let's say x is equal to -1, what you will get? You will get the same thing. Because what I want to say, axis is equal to -1 simply means last axis. It simply means last axis. Fine. And if you write axis is equal to 0, then things will be maybe something different. So let's also do it. So in this case, the result is different, because axis is equal to 0 means you are doing a row wise, and axis is equal to 1. We have already discussed this thing. Now one last thing that is there is standard deviation. You can also calculate this thing, std x.std. If you will simply do, it will give you the standard deviation. What is a standard deviation? So a standard deviation basically how much is away from the mean values, that is the standard deviation. We will discuss these things in the statistics. So this is the standard deviation. So what's the time right now? Fine. So I suppose this is fine for today's, and we will continue. Still we are not done with the NumPy. Next time when we will start with a very important concept called broadcasting and array shape manipulations. Then we will discuss dimension shuffling, and I suppose lot of, and also we will discuss this flattening operations, flattening thing. So these things we will discuss in the next session, and then I will see whatever thing will left, we will cover it in subsequent sessions. So is this fine for you, Varun?
Yes, sir.
So let me upload this code on GitHub. So let's push this code. So session,
सर जो आप एडवांस पाइथन करवा रहे हैं यूट्यूब पे,
एक सेकंड पहले इसको कर लेते हैं, फिर करते हैं. Session 3 of NumPy completed. Let's commit the code. Yes. Sync changes. Okay. Fine. So this is my post. My code has been pushed to GitHub. So I can I stop sharing my screen? So I'm stopping the sharing of screen, and let me open my video so that we can have a little chit chat. So बताइए वरुण, कैसा लगा आपको सेशन? समझ में आया? कुछ फीडबैक पहले आपसे, मेरे को फीडबैक चाहिए, ठीक है? और
सर आ गया सर,
आ गया समझ? अपना वीडियो ऑन कर सकते हैं? अभी बात करते हैं, वीडियो ऑन कर लीजिए. हाँ. तो
सर जो आप एडवांस यूट्यूब पे करवा रहे हैं अभी, उसमें आप ऊप्स ही करवाएंगे और कोई भी टॉपिक है ऊप्स के अलावा जो आप उसमें करवाएंगे?
अभी तो मैं ऊप्स का ऑलमोस्ट एंड में हूँ, मतलब मेजर कॉन्सेप्ट्स हमने कवर कर लिया है. अभी कुछ कॉन्सेप्ट्स बच रहा है, जैसे कि एब्स्ट्रैक्शन मैंने नहीं कराया है, और कुछ कॉन्सेप्ट्स मैं पहले ही करा चुका हूँ, मतलब बेसिक्स पाइथन में ही मैं उसको कवर कर लिया था. बट अभी मैं उसको वापस से रिपीट करूंगा. जैसे कि मैं एक्सेप्शन हैंडलिंग कवर कर चुका हूँ पहले ही, बट फिर मैं उसको रिपीट करूंगा. अब इस बार मैं क्लासेस एंड ऑब्जेक्ट क्लासेस के साथ उसको एक्सेप्शन हैंडलिंग को यूज करके दिखाऊंगा. जैसे लॉगिंग का सेशन, देन वी विल टॉक
So guys, those of you who are watching my recorded session, you can take the inspiration from Arun. He is a very sincere student, and he is very diligent student. He is very hardworking, and so keep coming, keep learning. So let's end this session, and we will be meeting tomorrow again. Varun, please wait.
Thank you, sir.
Please wait.